Okay, so this video is for Fourier's law of conduction, and this is the first in a series of quickfire videos that are designed to help you get that maximum exam mark in the minimum amount of revision time. So let's start by imagining that we have an object. Now I'm going to apply heat to one side of that object, but then we can see that we now have an unknown. How much heat would be coming out of the other side of the object? That is to say, how much heat would be conducted through the object to the other side. Now we have a series of knowns that we can use to help us calculate that. The first is A, the area across which we're applying that heat. The second is D, the distance that that heat needs to be transferred through the object to reach the other side. The third is the temperature difference or gradient between our heat source and the object itself. In this case, we can see that the heat source is at 30 degrees C and the object at 10 degrees C. So we can say that that object would warm up and therefore there would be more conduction of heat through it. Lastly, we have this property where some materials are better at conducting heat than others, so we have to consider the thermal conductivity. So we have four things to consider: the area, the temperature difference, the distance that the heat is travelling through the object, and thermal conductivity. We can roll all of these factors together into an equation that we call Fourier's law. Take a minute now to pause the video and write down the equation. Now you may see this equation expressed in different forms from different sources. You may see D written as L for length instead. You may also see this equation expressed as Ka dt over dx. The reason we've chosen this form for this video is because the goal of this video is to get you to that correct exam answer as quickly as possible. And we can easily remember this form by saying cast D. Let's look at what each of the terms mean again. We get heat flow watts. So heat flow in watts, the rate of heat flow, is what our equation will calculate. We have K, which is our thermal conductivity, A, which is the area, and delta T, which is our difference in temperature. And please note, as we're looking at difference in temperature, it doesn't really matter for getting the correct answer whether we use Kelvin or degrees C, because it's the difference between the two that matters, and it would be the same whether we use degrees C or whether we use Kelvin. And lastly, thickness of the surface, which is in meters. And I'll underline the fact that it's in meters, because very commonly in City and Guilds exams, they're going to try throw you with that part, as we'll see. So next then, let's look at a practice question. Take a minute now to pause the video and read the question. Now, good practice for any exam is to highlight the information that you are given in the question as a first step. So let's do that now. You can see the information we've been given here is that we have a thickness of 280 millimeters, an area of 25 meters squared. We've got two temperatures here, 21 degrees C and 2 degrees C. And therefore our temperature difference is going to be 19 degrees C. And we have a thermal conductivity of 0.7. So before we move on, we're going to do two things. Firstly, we're going to remember our method of remembering our equation, cast D, Ka delta T divided by D. The next thing we need to note is that they've already tried to throw us with the question. They've given us a thickness in millimeters rather than meters. Therefore, we need to convert the millimeters into meters. So converting 280 millimeters into meters, we get 0.28 meters. If we now then plug those numbers into our equation, we have 0.7 for our thermal conductivity, 25 for A, our area, and 19, which is our temperature difference between that 21 and 2 degrees C. We times all those together and then divide that by 0.28, and we get 1187.5 joules per second. That is to say our final answer is 1187.5 watts.